Okay, we start the recording. Again, we should see this remarks about the assignment one. Again, we have sent the emails and posted these messages on the blackboard, so you can check it again before you submit your final versions for the assignment one. And next, we will talk about the prototype. And in the tutorial, some students see that actually the prototypes are good programming habits instead of a must. And here I want to explain and let you see whether the prototypes are just the good programming habits. In our courses, in our lectures, we just use some simple examples, very simple examples for the C to learn the C languages and to learn the programming. However, so in our lectures, for those simple examples, you can write all the things in a one file, right? You can write all the things in a one file because your task is really because your I first explain this prototype and see your question. So in fact, you can write all the things, all the functions in one file because the problem is very easy. However, in the real world projects, you can think about a complex project. In fact, the operating system we used for the Mac OS or the Linux, they are based on the C language. So for those big projects, we cannot write all the things in a one file for the C file, right? So we have to use multiple files, and also another situation is that when we collaborate with others to finish one project, we need to write different files from different persons and then merge those files into a large project, a whole project. So in these situations, we need to write the code in different files, and sometimes in fact, different files may include the different functions. So in these cases, we indeed need the prototypes for the functions. So for this reason, remember to include your prototypes in your assignment, quizzes, and examinations. It will help you to avoid some errors in the real-world projects. Do you have any questions for this prototype? For the assignment one, you can only use the 3.4. You cannot use the other statements, such as the .4, star, 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 and other space here. If you have no other questions about the prototype, we can continue. Do you remember this example when they left in the last lecture? Do you try to solve this problem for this example? Yeah, it's great, and I see the Carville has tried to solve this problem. And do you have any questions about the solutions showing in the slides, in the next slide? Yes, I see the Carville has no questions about the solutions. Yes, it's relatively complex questions in this lecture. However, it's really a simple questions in the real world problems. So if no one has questions for this problem, we may start our lectures. Okay. Let's start today's content. Hello, everyone. Welcome to the lecture Programming Fundamentals. And also to make sure the quality of the online course, I will mute your microphones. And if you have any questions, please type them in the chat box. And answering the question one by one is not workable due to the time limitation. So I will select typical questions related to this lecture to answer. And if your questions are not answered during the lecture, I will stay behind after this lecture if you want to consult me. Today, we will continue to learn the C functions, and there are our learning objectives today. First, we will learn the storage class, the storage duration, scope, and the linkage. And also, at the last lecture, the lecture of the function 1, we have learned how to call a function in another function. And in today's lecture, we will learn how to write and use the functions and call themselves. Now, let's see the identifier. And we have learned and used the identifier before. And in the first 3 lectures, we used identifiers for the variable names. And the attributes of the variables include the name, the type, size, and the value. And also in the last lecture, we also used the identifiers as the names for the use-defined functions. And actually, each identifier in a program has other attributes, not just be the name for the variables and the use-defined functions. It also has other attributes, including the storage class, the storage durations, the scope, and the linkage. First, we will talk about the storage class. The storage class will determine its storage durations, scope, and the linkage. And the C language, C, provides the storage class specifiers, including the actual register, the external, and the static. And we will learn those different storage class specifiers later, one by one. And then for the storage durations, the storage duration is lifetime for during which the identifier will be in memory, and some identifiers are repeatedly created and destroyed, and also some other identifiers may be leave and extras for the programs, the whole executions. So different identifiers may have different storage durations. And next, for the scope, an identifier scope is where the identifier can be referred in a program, which means in which part in this program we can refer to the identified and can use this identifier. And last, about the some scope means that some identifiers can be referred through the whole program, and other identifiers can only be used for in some special parts of the program. And finally, for the linkage, and identifiers linkage will determine us for multiple source file or program, and whether the identifier is known only in current source file or in other source file with some declarations. For example, in the last lectures, we use 2.c file and 1.h file to define the functions and functions, and another and call these functions in the main functions. And we can use functions in different source file. So this is implemented by the linkage. And this lecture, we will discuss the storage classes and the storage durations and the scope. And first we'll talk about the storage classes. And the storage class will determine its storage durations, the scope, and the linkage. And C provides the storage class specifier, the external, the register, and the static. And we will learn them one by one. First, the storage class specifier. Those four class specifier can be divided into two types. The first is automatic storage durations, and the other is static storage durations. And the keyword the arrow is used to declare the variables of the automatic storage durations. Which means if we use the arrow in front of the name, in front of the identifier, then this variables will be declared that it has automatic storage durations. And the variables with the automatic storage durations are created when the block in which they are defined is entered. And they will be while the block is active, and they will be destroyed when the block is exited is returned. And only the variables can have the automatic storage durations. Functions local variables, those variables declared in the parameter list or a function body, they are the local variables for the functions, normally has the automatic storage durations. And the keywords will explicitly declare the variables of the automatic storage durations. And the local variables has the automatic storage durations by default. So the keyword auto can be removed. And for the remainder of the lectures, we will refer to the variables with the automatic storage duration simply as automatic variables. And then we'll see more about the static storage classes. The keyword, the external and the static are used in the declarations of the identifiers for the variables and the functions of the static storage durations. Those are two different specifiers. And the identifiers of the static storage durations will exert for the time at which the program begins to execution and until this program stops. And for the static variables, the storage is allocated and initialized only once before the program begins execution. And for functions, the name of the functions will access when the program begins execution. And however, even though the variables and the functions names exit from the start of the program execution, this does not mean that those identifiers can be accessed through the whole program. The storage durations and the scope are different things, as we will see in the following slides. And there are several types of identifiers with the static storage durations, the external identifiers, and the local variables declared with the storage class specifier static, and the global variables and the functions names are of the storage class external by default. we continue to talk about the static storage class. We have known we can use the. Okay, we have some basic concept for the static storage class, and the external and the static keywords are all declared for the static storage identifier. And I see that the King Hao has asked that how about the register keyword? In fact, as we know, we have knowing that our variables are stored in the memory, right? In the memory of the computer. And however, if we use this keyword, the register, which will means that we do not store these variables in the memory. However, we should keep these memories in. We should keep these variables and its values in a register. The register is a hardware in the middle level languages. So, which means that you do not want to put those variables in the memories. You should put it on the register, and the register is one of the another concept for the computer. And in this lecture, we will not learn it. So, for now, in these lectures, you will not use the register. And by the way, as we have seen that if we use the register keywords before variables, we see that we should put these variables in the register instead of the memory. However, in the real cases, the compilers will not follow your instruction always. Sometimes it will maybe follow your instructor, really keep these variables in the register. However, even you have declined that the register keywords for variables, the variables still can be stored in your memory. It depends on the compilers, and we cannot control it. So the register keywords for our courses, for our course, the programming fundamentals, we will not use this register keyword. Okay, now we can continue see the static storage classes for the external keywords. Now the external is used for a decline for the global variables. So far we have all the variables we have seen is the local variable. Now we can see the global variables. External and the static, the specifiers to decline that the variables or the name or the functions has a static storage class, and the external and the static has different use. The global variables and the functions names are of the storage class external by default. So, global variables are created by placing the variable declarations outside any function definitions, and they return their values through in the executions of the whole program. And the global variables and the functions can be referred by any functions that follows their declarations or definitions in a file. And this is one reason for using the function prototypes. When we include for example, when we include the standard input and output header in a program that calls the printf functions, the function prototype is placed at the start of our file to make the name printf known to the rest of the file. And the definition and the defining variables as a global rather than the local will allow the unintended side effects to exist when a function that does not need access to the variables accidentally or modifies it. In general, the global variables should be avoided, except in some special situations with unique performance requirements. And the variables used only in a particular function should be defined as local variables in that the functions rather than as external variables. And we have talked about we can use external to decline the global variables as a static storage class. And also for the local variables, we can decline with a keyword static as still allowing only in the functions in which they are defined. But unlike the automatic variables, the static local variables can return their values when the function is executed and the leg is returned. And the next time the function is called, then the static local variables will have the value it had when the function last returned. And the following statement declares the local variables count be the static and initialize it to the 1. And all the variables of the static storage durations are initialized to the 0 if they are the int or the float. They will also the variables will be initialized to the 0 by default if you do not explicitly initialize them. And the keywords external and static have some special meaning when they're explicitly applied to the external identifiers. And in future, we will discuss the explicit use of the external and the static with the external identifiers and the multiple source file programs. Next, we will talk about the scope rulers. The scope of identifier is a part of the program in which the identifier can be referenced, can be validated. For example, when we define a local variable in a block, it can be referenced and it can be validated only following its definitions in a block or in blocks listed within the block. So the 4 identifier scopes are the function scope, the file scope, the block scope, and the function prototype scope. And the identifier declared inside the function has a function scope. And then for the file scope, identifier declared outside any functions, it has a file scope. And such identifier is allowing in all the functions from the points at which identifier is declined until the end of the file. And also next we can also the global variables, the function definitions, the function prototypes placed outside the function all have the file scope. And the local variables defined at the beginning of the function has block scope as dual functions parameters, which are considered as the local variables by the function. And any block may include the variable definitions. And the identifiers defined inside the block will have the block scope. The scope will have some other rulers. For example, when the blocks are listed and an identifier in an out block has the same name as an identifier in an inner block, then the identifier in the out block is hidden until the inner block stops. This means that while executing in the inner block sees the value of its own local identifier and not the value of the outer identifier, and the local variables declined. The static still has a block scope, and even though they will exist from before before the program start up. So therefore, the storage durations does not affect the scope of the identifier, which means that identifier which means that the scope and the storage durations are 2 different things. And the only identifiers with a function prototype scope are those used in the parameter list of the function prototype. As mentioned before, the function prototypes does not require names in the parameter list. Only the types are required. So if a name is used in a parameter list of the function prototype, then the compilers will ignore or neglect the name, and so the identifiers used in a function prototypes can be reused elsewhere in the program without the ambiguity. Here are examples. These examples demonstrate the scoping issues with the global variables, automatic local variables, and the static local variables. After seeing these examples, you will have more clean understanding for the storage durations, the identifiers for the global, automatic, and the static local variables, and as well as the scope, the storage scope. Okay, maybe you can first go through this code and print your answer on the chat box. You can remove those strings for the descriptions for the different x. You can just type the values for different x at different lines to the chat box. And then I will explain why those x have different values and which x is referred in the print form. Do you have any ideas for the results for different x in different print4 function? Do you have any ideas for different results for the print4 function? You need more time to think about it, or I can directly to explain the results and run the code. Do you have any idea for the results? Okay, maybe let's start to explain the code. First, we can run it. You can see the code. Just see the code on the slides and guess the answer. Maybe I will directly to explain it. Okay, I should use to show this on. All the examples in these lectures, you do not need to type them on your own IDE. You can just see the code and guess the answer. So the answer are showing here. We can see that they have different. We can see that they have different values. But how we can generate and output those different values? Why these variables has this value? We can see it first at the main functions. At the 9, 11, first we print the x. And we can see that our result is 5, right? Because we have declined and defined a variable x, the local variable x in the main function, which whose value is 5. So when we print its value, it should be 5, right? For this print, do you have for this result, do you have any question? If not, I will continue for other print4 statements. If you have any questions, you can stop. You can stop me and type yes, you have questions on the chat box, or I will continue to explain the code. And then we can see we will continue to go to execute this code. So at this line, we need to print the value of x, right? And which value of x we should use? We have 3 different choices. The x is 1, the 5, and the 7. However, in the inner block, this is a block, right? So the most inner block is this. And in this block, the value of x is 7. So we should print 7 here. Because in this inner block, if we in an inner block, we will use the value in this inner block for this identifier and ignore the outer the identifier who has the same name in the outer block. And we can continue see at this statements. We should print the x again. And with y, this x is also 5 instead of the 7 because we have go out for the inner stock. Now we have in this local or locations for the main function. We have goes out for the inner block, right? So the value of x should be 5. In these positions, we cannot see the identifier in the other inner block. So at this line, we have we cannot see those informations for the x. Okay, those three statements will tell us that the inner block and the out block for the local variable. And let's continue to see the function. We define 3 functions: the use local, the use static local, and the use global. And we call these functions 2 times. First, now we will go to the first function in the first time, right? So we go to here. And in this function, we have seen that in this function, we defined a local variable for this function, x, whose value is 25. So when we print this value x, we should get the 25. And now we can increment x and print it again. Now we can see its value has been 26, right? Okay, then we will return to here and go to another function, use static local. So here we go to this function. And now we also, same as the use local function, we decline and define a local variable x. Why here we don't return after? Because it's just examples. We do not design to return the x. Why we should return the x? Oh, you mean we remove the return statements, right? If we do not write if the type of the function is void, we can remove this return. Which the C compilers will help us to do it. So in this static local variables, now we have our all local variables for this variable or for this function. So we should print 15 here. And we increment the x, so we should print the 41 here, 51 here. Right. So far there is no any question, right? So after we have yes, if the type is void, if the type is int, we must write a return a value for the int, or we will get an error. So we have returned here, and continue to do it. Use the global, and we can see that for this function we do not define a local variable for these functions. However, you need to find the x for this function. So the x, remember we have defined x at the beginning of the code is here, and this x is defined outside any functions, so it's a global variable. It does not belong to any local function, so it's a global variable. Because it's global variables, so it can be visited by all the functions. So here we will get the answer. The x is sorry, I should use the global here. So here we will get the global x value, which is 1. And now we will do some calculations. So we get the x is 10 after these calculations, right? Okay, the interesting things will happen. Now we call this use local again. And it will say that, okay, this time we defined x and its value is 25. Again, we can get the same answer as the first time. We can see that first we get the 25 here and 26 after these calculations, right? And then we return here and call this use static local function again. Here, our answer for this is 51 and 52. It's not 15, right here. This is why, because we use the static, the keywords, which means that the local variables for these functions will be created and initialized at the beginning, at the first time we execute these statements. So after we end this function at the second time, this statement will not be executed, and the x has already been in the memories at the first time, and its value is 51. We have C last time here. So now the result is 51 and 52. That's showing here. This is the use of the static keywords. And finally, we call the global function again. Here. Now we print the value of the x. The x is 10 instead of the can we delete the if we use the static? Here, if we remove this sentence, then the x will be a default. The x will be a 0 default. So I mean, if we remove these statements, then the x will be initialized at as 0 by default. We can see the x is 0, right? No, it can be any value. I just initialize it to the 15. Just like we initialize other variables we see before. It's just an example. We can do any value here in the between the range of the int type. For example, 16. Okay, let's say the use global function. Now we call or second call the use global function, and we can see that the output for the x is 10 instead of the 1 at the beginning, because we have changed the global value, the value for the global x at the first time when we call the function. So now we will print the 10 and the 100 respectively for those two statements. And finally, after we has called the function and return, then we should execute the last statements in this program. It will print the value of x. And we can say the value of x is the 5 because in here we reference to the x, the local variable x here in this main function. we do not access the X's in those functions. There are different X in different memories. Okay, do you have any questions for this example? It shows the global variables, the local variables, the inner and output, and the outer, the local variables in the inner and out blocks, and also shows the static, and also show the static local variables in functions. So it summarizes the content we learned in this lecture so far. Do you have any questions for this example? Okay, great. Why use global is 10? Here, you mean the second call, right? We can see that at the first time we call the global is 1, right? The first time is 1 because the global variable x is initialized to the 1 and here. So at the first time, the global variable x should be the 1. And the second time, if we go to the use the global function at the second time, then the value of x has already been 10 because we have do these calculations at the first time. So at the second time, the value of the global x should be 10. And why we don't need to type global or local? It's lunars, just like why we put int in front of a variable name to represent the type of the x. Just like y is 1 and 1 is 2, right? So it's just the those decisions for the C. The global variables in it will not. The global variables belongs to the global, not belongs to this function. So it cannot be destroyed by this function. So it's after the first time we call it, then the value for the global x will become 10, right? So after we call this function again, then now the global value is 10, and then for this sentence it will be after calculations in this statement, then x will become the 100. So we should print we will get the result 100 here. Because we change the value for the global x here. Okay, do you have any questions for this example? If not, we will start other important features in programming, the recursion. Okay, let's continue. And in these examples, global first we can see here outside the main functions, the global variable x is defined and initialized to the 1. And these global variables is hidden in any block in which a variable named x is defined. And in the main functions, a local variable x is defined and initialized to the 5. And this variable is then printed to show that the global variable is hidden in the main function. And next, a new block is defined in the main with another local variable x is initialized to the 7. And this variable is printed to show that this has the x in the outer block of the main function here. And this variable x with the value 7 is automatically destroyed when the block is returned is existed. And the local variables x in the out blocks of the main functions is printed again to show that it's no longer hidden. And the program defines 3 different functions that each take no arguments and return nothing. Here are the 3 functions. And the functions use the local defines the automatic variable x and initialize it to 25. And when use the local is called it, the variable is printed, incremented, and printed again before return the functions. And each time this function is called, the automatic variables x is re-initialized to the 25. And the function uses the static local defines a static variables x and initialize it to 15. And the local variables declared as a static return their values even they are out of the scope. And when use the static local is called, the x is printed, incremented, and printed again before return the function. And in the next call to the function, the static local variable x will include the value of the 41 of the 51. And the functions use the global does not define any variables. Therefore, when it refers to the variable x, the global x is used. When use global is called, the global variable is printed and the multiplied by the 10 and printed again before return before go out this function. And the next time the function use the global is called, and the global variable still has its multiplied value 10. And finally, the function will print the local variables x in the main functions again to show that none of the functions calls multiplies the value of x before the function or refer to the variables in other scopes. And here are the results for the different local, global, static, and the automatic variables x. Next, we will introduce the recursion. The recursion means that the function call it for functions, the function will call itself. And the programs we have discussed generalized structure as functions that call one another in a disciplined hierarchical manner. And for some types of the problems, it is useful to have functions call themselves. And a recursive function is a function that calls itself, either directly or indirectly through other functions. And recursion is a complicated topic discussed at the length in the up-level computer science course. And in this session and next, the simple examples of the recursions are showing here. Just some simple examples help you to know the recursion. And we can consult a recursion conceptually first. Then we will give several programming examples for the recursive functions. And the recursive problem solving approaches have the number of the elements in a common. And the and a recursive function is called to solve a problem, and the function actually knowing how to solve only some simplest cases or call it some basic cases. And if the function is called with a base case, then the function can simply return a result. And if the functions is called with a more complex problem, and the functions can be divided the problems into two conceptual pieces, and one piece that the function knows how to do, and a piece that it does not know how to do. And to make the recursion flexible, and the later piece must be looks like the original problem, but be a slight, simply or small version. And because this new program looks like the original program, and the function can cause a fresh copy of itself to go to work on a smaller problems, this is referred to as a recursive call or the recursion step. And the nature of the recursion has two rules. First is that one or more simple cases of the simple examples has a straightforward and non-recursive solution. And the second is that the other cases can be redefined in terms of the problems that are close to the simple cases. So for a large complex problem, we can divide it into some small parts, and we can solve some parts we have know how to solve, and then reduce the size of the problem. Now we will see simple examples to help us to learn the recursive functions. And this simple example is to recursively calculate the factories. And the factory of a non-negative integers n is a product of these forms. The factory for n is equal to the n multiply the n minus 1 and multiply n minus 2 and until to multiply the 1. And the factories for the 1 is 1, and the factories for the 0 is also the 1. And for simplified descriptions, we use the fn to represent the factories of the n. And the factories of integers, the number can greater than or equal to the 0 can be calculated iteratively use the 4 statements, and can be calculated in a non-recursive ways. And now we will see how can we solve this problem in a recursive. In a non-recursive ways, we can simply use the 4 statement to calculate the results for the fn, right? It's very simple. We just for n from the 1 to the number, and use variables to calculate, to multiply and it again and again, so we can get the result. So it can be very easy in a 4 statement, right? Now we will see that how could solve this problem in a recursive function, in a recursive way. Functions, and recursive definitions of the factory functions is arrived at by using the following relationships. We can see that the fn, the factory for n, can be equal to the n and multiplies to the fn minus 1, and which means that we can have these recursive forms for the factory calculations. And for a problem has the size n, the fn, we can reduce its size to the n minus 1. So the size of the problem can be reduced, and until we can reach the answer. For example, For example, this is the evaluations of the factory 5, the F5, and would persist as shown in this figure. And in the left figure, the figure A shows that how the recursive course proceeds until 1, and this until the 1 is evaluated to be the 1, and this 1. The factory for the 1 is the base cases, which will stop these recursions. And the B in the right part shows that the values returned from each recursive course to its corners until the final values is calculated and returned. For example, in the left part, first we want to calculate the F5. And we have known that the F5 is equal to the F to 5, and the multiply the F4. So we can write the F5 as these forms, and then we can continue to calculate the F4 as this more small size functions. Use the 4 to multiply the F3. And until we can find the 1. And after we get the value of the 1, we can return the value to get the F1. And then we have knowing the value of the F1, we can then get the value of the F2 and then return the value of the F2 to calculate the F3 and to calculate the F4 and calculate the F5, and until we can reach the final value. So how we implemented this idea? This figure used the recursions to calculate and print the factories of the integers from the 1 to the 21. And the choice of the type unsigned long int will be we choose the type of the unsigned long int because the value of the factory for the 21 needs the type the unsigned long int. And we can see that this function here, if we have the parameters, the number, which is n in our last slides, if the number is indeed less than or equal to the 1, then the factory returns 1. No further recursions is necessary and the programs will stop, right? And if the number is greater than 1, then the statements at the line 24 will be as a product of the number and a recursive cost to the factory evaluating the factory of the number minus 1. And the call, the factory number minus 1 is a slightly smaller the sample program than the original calculations the factory number. And the recursive factory functions first test whether a stop condition is true, whether the number is less than or equal to 1. And finally, the conversation specifier, the %, the LLU is used to print the unsigned non-long int values, and we have talked about in the last lecture. And unfortunately, the factory function produces a large value. So quickly that even unsigned non-long int does not help us print very many factory values before the maximal value of the unsigned non-long int variables is reached. So even when we use the unsigned non-long int, we still cannot calculate the factories beyond the 21. Do you have any questions for this code to implement the factory use the recursive function? The most important part is just those four lines. This is the basis cases. This is the base cases. When reach these cases, we should return the function and do not call the function again. And if we do not reach the base cases, then we should reduce the case, reduce the size of this problem, and then call this function again. So in this function, we call this function itself, right, with different parameter. So this is a recursion. Yes, the recursive steps we would calculate the factor until reach the base cases, as showing in the last slide here. Here, it will run this until it will call the 4 and call the 3 and call the 2 and call the 1 until the 1 has get the results and return to it, get the answer of the F2 and get the answer of the F3 and get the answer of F4. So it do like first call the function and then get the value of the function step by step. So if we remove this sentence, what will happen? If we remove this sentence, we just return this statement, and we remove anything else, just keep this sentence, keep this statement. If we delete all of this, just leave this statement, what will happen for this code? Yes, it cannot print anything for. It cannot print anything. Cannot print anything for. Yes, if this sentence has been removed, we just give this statements. What will happen? So in these functions, all the things are. We should think about it. If we do not return this function, right, then the function will be called again, and again. So the function will always call itself. What will happen? Just like we will never return and except for the for statement. So if we do not have this sentence, then we after the number becomes 1, and then we will call the factory 0, right? We call the factor 0, and then the factor 0 tells us you should call the factory -1, and you should continue to call the factory -2. And it will call factory -5. So these functions will never stop, and this program will never stop, and these functions will never return to the print4 statement. And it calls it again, and again until it has used all the memories for the computer, and it crashed. So remember, if we use the recursive function, remember we need to have the return condition. In which condition, when we retrieve the best case, we should return and do not call the function again. Otherwise, we will always in this function call. Just like the infinite iteration, it will achieve the infinite function call. Okay, do you have any questions for this example? If not, we continue to say another example. The choice of the type of Okay, let's see another examples. The Fibonacci series. Many of you, I believe many of you have heard about the Fibonacci series. The Fibonacci series is a series of integer numbers, as shown here. The 0, 1, 1, 2, 3, 5, 8, and so on. And the Fibonacci series may be defined recursively as follows. The Fibonacci 0 is equal to 0, and the Fibonacci 1 is equal to 1. And then the Fibonacci n is equal to the sum, the sum of the two Fibonacci values of the Fibonacci n minus 1 and the Fibonacci n minus 2. So based on these definitions of the Fibonacci series, and could you write code to print a Fibonacci series? Here are the core part of this this program. We have defined a Fibonacci. We have given the function prototype of the Fibonacci functions, and also provides the main functions here. Could you write the Fibonacci functions, the definitions of the Fibonacci functions, to in a recursive way to calculate to get the Fibonacci series? Okay, giving n, this is the prototype for this function, and giving the n, you should return the value for the fn for the Fibonacci series, the n, fn, Fibonacci n. So you can try it. You just need to write the core, the definitions of these functions. Maybe I give you 5 minutes. The implement for the corrections in these examples is not very complex. If you finish this task, you may type in the chat box to let me know. This recursive format, these calculations will help you to write the recursive function. Do you finish this function? Write the code for the definitions of this function. It's very similar to our last example, just has different base case and different calculations for the recursive calculation. Just have different calculation, but the statements and the logic is very similar to our last example. Do you need more time to maybe 2 minutes, or I directly to show the solution for you? Okay. It's very similar to our last example, just changing the base case and the calculation. Maybe we should continue. And if I show the solution to you, you will see that the solution is really similar to our last example, and it's straightforward and naturally. Equal to 0. It's to get the Fibonacci series. Here are the implementations of the functions, the Fibonacci functions. Each time the Fibonacci is invoked, it will immediately attest for the base cases. The n is equal to 0 or to 1. And if it is true, the n is returned. And interesting, if n is greater than the 1, then the recursion steps will generate 2 recursive calls, each a slightly simple problem than the original calls to the Fibonacci n. Let's invoke it. Sorry, there is a mistake. The n should be in the first, and the 0 should be on the right side. The 0 should be on the right side, and the n should be on the left side, as well as this expression. And we can see that when the n equal to yes, thanks. There is a mistake. And we can see when we reach the base case, the n equal to 0 or 1, we can return the results. We can return the value we have known for the base case. And here, if we do not reach the base case, then we should use the calculations for the definitions for the Fibonacci series. So the calculation is the fn minus 1 and plus the fn minus 2. It's very easy and straightforward, right? Do you have any questions for this example? And for the solution? So if we begin from 1 and equal to, however, if I put the n equal to 0, how can we solve it? If we begin from the 1, if we start 1, then we cannot solve the situations when the n equal to 0. Or you can write if n equal to 0, what's the value, and if. Yes, you can divide the in many base case. However, you cannot list all the cases for different n, right? Yes, you can use different sentence. Yes, you can use different sentence. You can use multiple statements for different if statement for different situations. If n equal to 0, then do something. If n equal to 1, then do something like that. And my computer says that the LLU is a knowing conversation type character. Yeah, maybe it depends on your compiler, the different and your computer environment, the system. If you cannot use it, you can change it to non-int, and also you cannot use the 21. you can use the small number for the n. Maybe you should use a small number as the n, not the 21, because it will extend. It will the value of the 21 will larger than the range of the non-int. Unsigned int. Line 10. I see it. In your code, right? N should be. Sorry, I don't know the problem. My compiler tells me in line 10 do not correspond to unsigned non-int. Yes, U is corresponding to the unsigned int. And I think the Ziqiu asked the problem for the last example for the factory, right? If you do not have any questions for this example, maybe we can continue. And later you will see complex examples. But it's very interesting and it's a very famous problem. Fibonacci is invoked. It will immediately attest for the base cases. The n is equal to 0 or to 1. And if it is true, the n is returned. And interesting, if n is greater than the 1, then the recursion steps will generate two recursive calls, each a slightly simple problem than the original calls to the Fibonacci n. This figure shows how the function Fibonacci will evaluate the Fibonacci tree. And this figure will raise some interesting issues about the order in which C compilers will evaluate the operators of the operators. To symbolize the descriptions, we will use the if to represent the Fibonacci. And this is different issues from the order in which the operators are applied to their operands, namely the order dictated by the rulers of the operator's precedence. And this figure shows that while evaluating the F3, then the two recursive calls will be made, namely the F2 and the F1. But in what order will those two calls be made? You may simply assume that the operands will be evaluated left to right. However, the C does not specify the order in which operands at most of the operators, including this this AND operator. So they cannot be evaluated in a defined order. Therefore, you should make no assumptions about the order in which those calls will be executed, and the calls would in fact can first calculate the F2 and then call the F1, or the calls could be in a different order. First, call the F1 and then call the F2. So in this program and in most other programs, the final results would be the same. But in some programs, the evaluations of the operators may have side effects that could affect the final results of the expression. And say specifies order of the evaluations of the operands of only 4 operators. They are showing here, the and, or, the comma, and the operator, comma operators, and this condition, 3 condition and operator. And the first 3 of those are binary operators who are guaranteed to be evaluated from left to right. And these operators, we learn it as the if-else section, and its leftmost operators is always evaluated to non-zero. Its leftmost operator is always evaluated first. If the leftmost operand evaluates to non-zero, then the middle operand is evaluated next, and the last operand is negated. And if the leftmost operand evaluates to 0, then the third operand is evaluated next, and the middle operand is neglected. We have seen that, and the King Hall asked a question about, so add the increment operators to ensure the evaluations from left to right. In fact, only those 4 operators shown here can make sure the order for the function call. So in these cases, the increment operators cannot call the functions to ensure the functions is called by the from left to right. Remember, we have talked about the order for the operators, for the expressions, calculate the expressions for the variables. There are different things. There are 2 different things. Those orders for the expressions to calculate the variables are not the function call order. Those 2 orders are 2 different things. And in the function call, in this function call, recursive function call, we cannot, the increment operator cannot call the function from left to right. Only those 4 operators can have some order. Operand evaluates to 0, then the third operand is evaluate. All the in some recursion functions, recursion menus can also be solved in a iteration methods, such as use the for, while, and do while statement. So in fact, every program can be solved using the recursion functions can be transferred to the iteration methods. But what's the difference for those 2 different methods? Both the iterations and the recursions are based on control statements. The iterations uses repetition statements, and the recursions use a selection statements. It uses a selection statements if we if we achieve the base cases, then we do something. And if we do not array the base cases, then we will try to get a simple versions of the function. And second, both the iterations and the recursions involve the repetitions. The iterations explicitly use the repetition statements, and the recursions achieve the repetitions through the repeated function calls. And third, the iterations and the recursions each involves a stop test, the condition. The iterations will stop when the loop continuations, the conditions fails, and the recursions when a basic cases is recognized and reached. In fact, the recursions may be more expensive than the iterations. The reasons are: first, it will repeatedly invoke the function calls. It will continue to call the functions. And second, and this function calls will be expensive in both the processor time and the memory space. And each recursive calls will cause another copy of the functions, actually only the functions variables to be created. And this can be consume the considerable memory. And as a comparison, the iteration normally be within a function. So the overhead of the repeated functions calls and the external memory's assignment will be removed. And the amount of the memory in a computer is finite. So only a amount of the memories can be used to store the stock frames on the function call stock. We have talked about the function stock at last lectures. So if we use the recursive calls, then we will store remaining function call stock in the stock. So it will also use our memory, and the memory of the computer is infinite. So the recursions can be expensive. However, why we still learn the recursions, and in which cases we should use the recursions? And there are two cases in which you use the recursions instead of the iterations. The reasons are: first, the recursive approaches are more naturally to simulate the problem and results in a program that are easily to understand and debug. And later we will see examples, and this example will help us to know why the recursion is more easily to understand in the for the compared to the iterations. And second, choose the recursive solutions is that iterative solutions may not be apparent. Sometimes the solutions for the recursive methods will be more literally and directly. And for example, when we write the search binary tree in the data structures, if you learn some data structure courses and some algorithms courses in computer science, then you will learn the search binary tree and the quick sort and so on, many complex problems. In those problems, you can easily implement their functions in using the recursion functions. However, if you want to use the iteration methods, then the code will become very complex, and the logic to implement the code will be complex. Next, we will see a very interesting problem, the Tower of the Hanoi. The Tower of the Hanoi is a very interesting mathematical problem where we have 3 rods and n desks from the large to the small. And the objective of this problem is to move the n desks to another rod and using the following simple rules. First, only one desk can be moved at a time, and each move will consist of taking the upper desks, the most up desks, from the one of the 3 rods and placing it on top of another rod. And the desk can only be moved if it is the uppermost desk on the rod. And the third is that no desk may be placed on the top of a small desk. For example, there are 3 desks. There are examples for the 3 desks here. There are red, the white, and the green. These 3 desks, and they are placed from the largest to the small. and we have 3 rods here. And at the first step, we should to move this small, this red desk to the third rod. And the second step is that we move the white desk to the B, and then we could move the red desk at C to the B. So after 3 steps, the A has a green desk, and the B has a white, and the red desk, and the C is empty. And then next we can move the green at A to the C. And at the 5th step, we could move the red to the A. And then we can move the white at B to the C. And finally, we can move the red at A to the C. So we can finally move the 3 desks, the red, white, and the green, to the C. Do you understand this problem? This problem of the Tower of Hanoi. It's a very famous problem. Yes, great. So now you can try to solve this problem using recursion. And the input of you should write a function to solve this problem. And this function can call itself. And the input is n. N is number of the desks. And you should output the steps to move these desks from the desk A to C using the another road B. So you need to write a code to show the process when we input n, how we can follow your output from your program to move those desks. The hint is that use a recursive function. And for example, after we move the first step like this, then we finally need to move those 2 desktops to the B, and then we can move the C to the B, right? So the size of problem is reduced. And the problem is similar to the original problem. So we can use the recursive function to solve this problem. Maybe I write the main functions for this problem, and you write the definitions, the code for this function. Yes, not the number of the total step. The result should be how every step to tell us how to do the process, including every step, how we should move. For example, move. Maybe it outputs like move the first desk to at A to B, and like this, and continue to move the second to something like this. In step 2 and 3, the red desk could move to the top of green desk, and it become complicated. How can I do the code? The step 2 and 3, the red desk could move on the top of green desk. It will become the a very important part for the recursion is that you do not need to consider many following steps. Just focus on the correct stop, because the current stop will be solved by continue calling the function, right? So do not think about many steps. Just focus on correct stop at this time. Think about at this time what should do, what can I do in this function. You don't need to think about maybe the process can be more complicated if I do something, right? Just focus on correct step. Even the situations become complicated, then it will be solved by the function itself, by continue calling itself, right? Maybe I write the main body of this. Yes, just if we have the input is 3, the n is 3, we have 3 disks, then the 7 steps can solve this problem. And if n is maybe large, maybe 4, 5, 6, then the process may be more, we need more steps. So your code need to tell us when n equal to different values, how should we move those disks? You can try this, and in fact, if I show the code for you, you will say, oh, the answer is really easy, and the statement is easy. How about maybe the logic? Why we can do something like this? It's not so straightforward, maybe. For example, I write the body of the Yes, there are only 3 rows in total, and n is the number of the disks. Yes. So if you input other value, and you can check the answer, you can check your answer from your program by do the process output from the your program by yourself to check it. There are three parameters, which means that which rows we should move this desk at this time, and which route we should achieve in this task, and the remaining task is which. It not always refers to the A, C, B, and because, for example, at the beginning it is A, C, B, right? At the beginning. However, in these cases, it may be the for these steps it may be the B, B, A, C, right? At the beginning, it refers to the A, C, B. Yes, means yes, not moving at this step, just at this step, because we will use all those different roads in the whole process. So just at this step. So you need to write the statements inside this function. Maybe after 3 minutes, we will start to talk about the solution. you can think about what is our base case, and if our base case is reached, how should we solve it? And otherwise, if we do not enter the base case, how should we solve the problem to reduce the size? How should we move the desk at current step, just for current step? Do you have any idea to solve this problem? If not, maybe you can follow me. We solve this problem together and see the logic behind those statements. Why we can solve it in these statements, and how we retrieve and how we think out those solutions. Okay, maybe you can stop your maybe you can stop to typing your code and just follow me and follow the logic behind this problem. Okay, so first let's think about the base case. The base case is if we have only one desk, so what should we do? We can just we can just very simply we can just remove this one desk to our two rows, right? So the best case is if n equal to 1. In these cases, the solution is very easy, and we can know how we do it. Then we can print for move this desk 1 from one row to another row, from the front row, right? We can simply move it, right? And we can return. Do you have any questions for this statement? For the base case? So the base case is that means the character for the character type, the conversation specified for the character type. So the best case is it's very easy, right? Our human can solve it in a very straightforward way. Else, if we do not reach the best cases, how should we do? We have n desktop now. We can just move the upmost top desk, right? So we should move So our solution is that, for example, we have many desktop on here. Then what should we do? We should move all the n-1 desks to another row. And then we can move our last one, right? But this case is restricts moving from row A in calling function. Yes, because n is equal to 1. It just moves from to 2. if each one is A and C. It's A and C. Or A, yeah, we need to move to C, for example. Because those three parameters are not always corresponding to A, C, B respectively. They are not always corresponding to the A, C, B respectively. So what we can do is that we can just say, okay, you should help me to move the n-1 desktop to the front row, which means that we move those two desktop, right? We move those two. It will ask the code, ask the function to help us to move those two desktop to the second one, for example, to the it will tell us that you should put the desktop n from the front row to the reminding the other rows, right, in the stuff. And we do not know how it exactly do, but we ask the function to do it. In these cases, the function will help us to move those two desktops to the B, right? So in these situations, we can just move the last one, the green part, to the C, right? So we will ask move desk n, and now the n is D. Move the n, we use move the n to the row from the row C to right. We move the largest now n to the from and the two. Sorry. Right, we have moved those two to the remaining B, and then we can move the final one to our two rows, the C, right? And finally, we can call, okay, those n-1 desks. Now you can move to C. Right. So we do not need to think about how the functions move those n-1 desks. The function will solve it by itself. We just need to think about at the current step, what should I do? What should we do? So it's really easy. Why not there is no n? Because the n is equal to 1. Yes, because the n is equal to 1 at here, so we just use 1 in the string. And however, in these situations, we just know we should move the n desk. we do not know the number, the value of the n, so we need to print the n. So the statement, the implement is very easy, and we can run it. For example, I input true, and it will tell us the process. Also, we can use more for, then it will need more steps. C, line 22. Yes, it will move the remaining n-1 desks to the C at current step. But the true root is not always C, right? For example, maybe in here, for example, in this step, we move the right to the B. So the true root is not always C. We cannot write the C character directly. We should use the variable. The from, the to, and the other variables are not always corresponding to the A, C, and B. When the calling different functions in different steps. Yes, for example, just use this example, not represent the whole code, okay? This example, we move those two. So this 9, 20 is that we move this 2 to here, right? And this 9, 21 means that we have moved this to B. So the 21 is that we move this green to C. And this 9, 22 is that, okay, we move this 2 in B, the red and white to the C. So we can find the answer. If we do not include the last 9, then those tasks will be divided into 2 rows, the B and the C. And the n-1 desk is in the B, and the n desks will be a C. Do you have other questions and any further questions for this example? We can see that we can use very simple code, very simple program to implement very famous problem. And when the n is very large, our humans cannot very easily to get the answer. However, the computers, when by using the C programming, we can easily get the answer for those steps, even when n is very large number. Okay, do you have any questions for this example? Yes, if no questions, maybe we can talk about something about array because we still have some time. Okay, this is exam code. And after this lecture, we will release the assignment 2. And but because we have some time, so we can start to introduce the array in this lecture. However, for the questions in assignment 2, you are not allowed to use array to solve this problem. Because assignment 2 is designed to make you to use the if, switch, the for, and the function, and the recursive function. So do not use array in your assignment 2. It is not allowed. In 20. In line should be 2 by replaced by you mean the 2 this or this? You mean this, right? We shouldn't replace it because it just tells us at the current step, well, how should we move from to another road behind the 2 behind. You mean this before? No, it's 2 road because we need to move the last one, the n desk to the 2 road. So it should be the 2 road. After this step, we only has 1 desk remaining in the A, right? In the front road. So we move this to the 2 road. Okay, great. So we can start the array. But remember, do not use the array to solve the problem in the assignment 2. We start to talk about array so that we can have some time to do the quiz after we introduce the array 2 in the next time, or in the lecture, maybe the lecture 7 or 7 maybe. You can refer to the schedule. So maybe we can today introduce some parts about the array. Hello, everyone. Welcome to the lecture Programming Fundamentals. And today we will introduce the array, which is important features in programming. And also to make sure the quality of the online course, I will mute your microphones. And if you have any questions, please type them in the chat box. And answering the question and use objectives today. Today we will learn the array and use the array data structures to represent the lists and the tables of the value, and learn how to define an array, initialize it, and refers to individual elements of the array. And also we will then define the symbolic consistent, which is unit in array to represent the size of the array. And also we will learn how to we will understand the security issues related to the input with the scanful and output with the printful and arrays. So we will learn how to use the scanf and printf to read and output the elements of the array. First, the arrays are data structures, and these selections will serve as introductions to the data structures. And the arrays are the data structures consisting of the related data items of the same type. And in the lecture 10, in the future, we will discuss the these notations of the structure, which is a data structure consisting of the related data items of the possible different types. And for now, we just focus on the data structures in consists of the items of the same type. And the arrays and the structures are the static elements in that they will remain the same type through the programming executions. And an array is a group of the contiguous memory locations that all have the same type. And to refer to a particular locations or element in the array, we specify the array's names and the operations number of the particular elements in the array. Here, let's see an example. Here is this figure shows the integer array called C, and it includes the 12 elements that are showing here. And any of those elements may be referred to by giving the array's name, followed by the position numbers of the particular elements in this square brackets here. And the array's name is C. And its 12 elements are referred to as C0, C1, C2, and until the C10 and C11. And the values sorted in the C0 is -45, and the value for the C1 is 6, and the value for the C2 is 0, and the C7 is 62, and the C11 is 78. So this is a simple example and a figure to help you to know what is an array. Now we will learn the array index, which will help us to index to get the specified elements in an array. First, the element in every array is start from the 0, which means that the first element in the array is the array 0, not from the 1. And array name, like other identifiers, such as the C in our last example, can contain only letters, digitals, and underscores, and cannot be behind with a digital, which is same as the other identifiers we introduced in the first lecture. And the positions number within the square brackets is coded as an index. And the index must be an integers or integer expressions. For example, if the A is given by 5 and the B is given by 6, then this statement, the C, A index C as the A add B and add 2 will be the segments will add 2 to the array C11 because A and B is 11. So index array name is L value, which means that it can be used on the left side of the assignment to help us to get the value and then change the value of the array. In fact, the brackets used to enclose the index of array we have seen before are actually considered to be operators in C language, and the they have the same level of the precedence as a function called operator, and which is a. And the first item in our array is called the zeros elements. It does not mean that the first item must. It does not mean the first elements. The value for the first element is equal to 0. It doesn't mean that. It just tells us that every array, the index is from the 0. For example, for the say A, for the say 0, it will tell us that the 0 will refer to the first item, and the 1, the C1, will refer to the second item in the array. Okay, 然后 the value of this element can be other value. For example, the 16. Bracelets that are placed after function name to call that function, and others. And the figures shows that the precedence and the social activities of the operators introduced to this point in this text. Now let's start to defining our arrays in our C program. Let's record that the array will be stored in the memory in a contiguous space, and these following definitions will keep the 12 elements for the integer array C, which will has whose index is from the 0 to the 11. And these definitions, the statements, those two definitions, will keep the 100 elements for the integers array B and the 26 elements for the double array X. And like any other variables, the unsigned arrays elements will include the garbage values. We cannot know the value of the elements in the array if we do not initialize this array. Here is an example to initializing an array. First, we can say type this example, and I will explain it. Now we can see this code, which will definition array and print a value in it. For example, let's start. You do not need to type this code in your OIDE, just see the screen. How to decline an array here? We decline an array which name is n, and this array n has 5 elements. And the type for the elements is an integer. So this statement tells us those things. And now from size, you can ignore the size t first. For example, from the int I equal to 0, I less than 5, and increment I, we initialize the n, every element in n to the 0. And then we can print for the array. We print for, I will explain this conversation specifier later after I type this statement. Okay, we can see that we have a ace, right? And we have another ace and a number 16. The first ace means that we have a string needed to print. So this will be printed by the first ace, right? And this is the other ace means that we print the second the parameters, which is the value, right? But what is the number means? The 16. means? It means that we will have a 16 space for the value. So after we use, if we do not use the 16, then the value will just follow the elements by one space, right? However, if we use this 16, then the value will use the 16 space for the value. For example, we can see there are many spaces between the element and the value, because the 16 is from here to here will have 16 space, including the five space for the value string. And now we can print the value for the element. This 7 has the same meaning for this 16. U means unsigned. Okay, and maybe I use D here. Yes, it's 13. I will talk the size T later. So we can print those elements and initialize the value for this element, right? If we do not initialize the value for the array, for example, we comment those statements, then we can see that the value maybe for the N4 is a garbage value, because if we do not initialize the value for the array, then the value for the elements in the array will be some uncontrolled value. In fact, we cannot know those values, so we should initialize the array. And now we can see that we use the size T here instead of the int, right? In fact, size T is yes, so I should change this to U. In fact, the size T is a type of the unsigned int. Because we need the 7 space for the number. For example, if we do not use the 7, then the 0 will be printed here. Should be printed here, right? It will tell us this 0 should 7 space. And this size T. The size T means that size T in fact is unsigned int, standard C standard type, not the unsigned int we learned before. It's a C standard type, and we will talk about it in the next slide. The later 4 is connected with the former 4. Later 4 is connected. It just print this sentence just print the elements, the value of the elements in an array. In the block, it prints the index and the value of the n array. It's the index and it's the value. So it will print the index, the first item, the value for the first item in the array is 0. Why we need the first 4? If we do not include the first 4, then we will not know the value for these elements in the array. We use this statement to initialize the value for these elements in the array. I will upload this PowerPoint after this lecture. Yes, it's to initialize the value of the elements in the array. So they can print 0, 0, 0 here. In output, the I is the 0, 1, 2, 3, and 4. The content in the for statement can be shorted and used for, okay. Sorry, I don't know slide for the sentence. However, we defined the n here. So this variable, n is a variable, right? It is an array variable, is an array. So we can use the array in the main function. We can use n in the main function. Just like if int t, and we put the t, and we can also use t here, right? Yes, if we initialize n to the 1, then output will be 1. For example, just like the variable, for example, it's t, and we set the t's value as 5, and we print, then the t will get the 5. So the same thing, just it's an array. It includes many items which has the same data type. Okay, maybe we can continue. I noticed that in the last examples, we use the variable I is declared to be the type of size t, right? In the last example, which will, according to the C standard, represents unsigned integer type. And this type is recommended for any variables that will choose array size or array index. And this type, size t, is defined in the header here, the standard defined header, and which is often included by any header, such as the standard input and output header. And so, in the last examples, we can use size t as for the type of the I to do the 4 statements. Because in different systems, the unsigned int and may have different range on different system and compilers. So the size t is a standard defined by the C, which has some range, and in order to implement uniform code in different platforms. However, in our lectures, in this course, you just need to remember that just can treat the size t as an unsigned int. It's not equal to unsigned int, and just for this course, you can treat it as unsigned int. You can treat it as an unsigned int. However, they are not equally okay. In more complex situation. Here are the other examples. We will initialize array using a predefined initializer list. And we have seen that we can use the 4 statements. There's 4 statements to initialize the value for the elements in an array. Also, we can use some simple measures to initialize the value for an array. For example, we can remove those lines and use something like this. It can also initialize the value for the n. We can see it. Okay, do you have any questions for this example? We can use the initializer list to initialize an array. Yes, you can, if this is 6, then you can type 6 value. And however, you can only type 5. You can only type 5 numbers. Then the sixth item will be the 0, will by default. We will say it later in the next example. Which means that we can use the initializer list to directly to initialize the array n. And the elements of an array can also be initialized when the array is defined by the following definitions with an equals sign and the braces here, and will including a common separated list of array initializes. And this figure initializes an integer array with 5 values and prints the array in the table format here. Also, if there are free initialized then the elements in an array, what will happen? Then the remaining elements will be initialized to 0. And for example, the elements of the array n in this example could be initialized as 0, as this follows in this statement. This will explicitly initialize the first element to be 0, and then initialize the remaining 9 elements to 0 because there are free initializers and there are elements in the array. And it's important to remember that the array are not automatically initialized to 0. So you must at least initialize the first element to 0 for the remaining elements to be automatically railroaded. And the array elements are initialized before the program starts up for standard arrays and at runtime for automatic arrays. And this array definition causes an error because there are 6 initializers and only the 5 array elements is needed. Because the range of the index is from the 0 to the 4, right? In the last example, so we can only access the elements in the array by using the index from the 0 to 4. If we can start from 3, but then we cannot reach the 0, the first element in the array, right? And this is another example. Yes, I is the index. So we can, for example, this is n, and this is a 2. So the 2 is the index. And in these situations, then I is the index. So the I should be in the range 0 to 4. Okay, this is another example. If we have many elements in an array such as 100, we do not want to initialize the value every element. For example, we don't want to write 0, 0, and write it 100 times. We can just write the first 0. Then the remaining elements in the array will be initialized to 0 by default. For example, we just initialize two elements. Then we can see the remaining elements in the 0. Right. So if we want to initialize all the elements to the 0, just like our last example, we can easily do it by initialize the first element at 0. Then the remaining elements will initialize to 0. So all the elements in the array will be 0. Can we change the 9 into 2, 5? I guess no, since. Yes, we can change it start from 2. Then we can only print 3 elements. It tells us, okay, start from the index 2 and just print the index 2 to the index 4. I just use 0 to show all the elements in the array. So the number in the initializer could be less than the size of the array, right? However, if the number of the number of the elements in the initialize, for example, is larger than the size of the array, what will happen? We can see it. Due to my compiler is optimizer, so it can get the right answer. However, in the standard compilers, it will raise error. So do not. So you need to make sure that the number in the initialize, the number of the elements in the initializer should be less or equal to the size of the array. Okay, do you have any questions for this initialization? If no, we can continue. So it will cause error. In some situations, we do not know the size of the array. So how can we initialize the array? Do not know the size without the array size. If the array size is removed from definitions with an initializer list, then the number of the elements in an array will be the number of the elements in the initializer list. In these examples, we do not explicitly giving the number the size of the n. However, it would create a 5 elements array initialized with the indicated values here. So we can. Here is the examples. These examples will. So when we define this array, we can remove the size of the array if we give the every elements in the array by using the initializer. So it's also correct. Initializing the elements of the array is to the even integers from 2 to 10. And this is an example which will ask us to initialize the elements of the array to the even integers from 2 to 10, which means that we should initialize the value whose elements will be initialized as 2, 4, 6, 8, and 10. We can initialize user for statements by using these statements, right? It first initialize elements of the 5 elements array to the value 2, 4, 6, 8, and 10, and then prints an array in a table format. And the values are generated by multiplying the loop counter by 2 and adding 2 here. Value 2. And we can notice that we use this sentence. This defined size 5, and then we use the size instead of the 5 here. Why? And we use the size 3 in three different places, here, and here. Why we use this sentence? Why we should define the size 5? Is introduced in this program. It will define a symbolic consistent size whose value is 5. And a symbolic consistent is an identifier which that is replaced with the replacement text by the C preprocessor before the program is compiled. And when the program is processed, all the symbolic consistent size are replaced with the replacement text 5. So using this symbolic consistent to specify the array size will make the programs more modifiable. In the next example, we would have the first 4 statement fill maybe 1,000 elements array by simply changing the value of the size in this sentence in this defined sentence. Then we would have we can change the 5 to the 1,000. So if the symbolic consistent size has not been used, then we would have to change the program in the 3 places. And by assigning a value to a symbolic consistent in a executable statement will be an error because the compiler does not receive the space for the symbolic consistence as it does for variables that hold the values at the execution time. So use only the uppercase letters. We can say that we use only the uppercase letters here for the symbolic consistent names. This will make those consistent stand out in a program and remind you that the symbolic consistents are not variables. And in the multiple void symbolic consistent names, we can divide the words with the underscores for readability. So, do you have any questions for this example? For this example, why we use the size? Why we use the symbolic consistent size here? Do you have any questions for this example? Which means that okay, every size appears in this program. For example, this size, and size will be replaced by the 5. So that if we change the size of the array, we can just change the value 5 to other value. We do not need to change in different places, in the 3 places. So usually we use the symbolic consistent to help us to define the size of the array. Do you have any questions for this example? If no more questions, maybe we can stop our lectures today. And thank you, and remember to submit your assignment, your first assignment on time. And the deadline is today, is within today. About lecture, notice C function. Yes, you can ask some questions. And if you have any questions, you can stay here, and I will answer your questions one by one. And for those do not have any questions, you can leave, and today's lecture is finished. We stop here, and next time we will continue to introduce the array. So, King Hong, do you have any questions for the whole statements of the function prototype? Its file scope, and why? The whole statement. Well, which means that these function prototypes can only be used in this file. The prototypes. So it's a file scope. And why? Everything defined in one file have the file scope, and other source files cannot visit them. So we need to use the linkage to linkage different source file. Every function defined in a one file has a file scope. Because you can think about if you are in another source file, it's very natural that you cannot see other contents in other source file, right? So the file scope is the function has a file scope. So we need the linkage to link different source file. I still do not understand. Okay, let's find the here. Okay, maybe I write a prototype. For example, we have a prototype void, and the function is if, and we have something such as int a and int b, right? So the function prototype means that those parameters in the function prototype can only be seen in this function prototype. So those parameters can only be read in the function prototypes. This is the function prototype scope. Those things has the function prototype scope. And because those things in the main function, so those things has a function scope. And this is a block, right? Such as I do something. And then this is a block. These things are in the block. So this variable, this identifies, has the block scope. And this function, main function, they are in the file. So this main function, the label, the identifier, the main has the file scope. So then, do I answer your questions? And do you know? Do you understand the different scope? This is a block. Everything in these two brackets are the block. So this identifier, the B identifier will have the scope, will have a block scope here. It's not global. The things outside any functions is global. For example, this C is global. this B will has a block scope. It can only be existed inside this block. In what further example? For the array. Oh, I know what you're meaning. If I use array here, right? You mean here, if I write, and it can be recognized, right? And do you mean, Tang, do you mean that? Oh, yes, because there are two different things. Because we defined the identifier here, right? So for the identifier n, its scope is the function scope. So everything in the main functions, it can be recognized this n. Because the identifier is defined here. For the question about the Fibonacci series, the operator means that zero calculates in the right place. Oh no, there are two different things. In the Fibonacci here, right? In fact, it will calculate. We don't know. It will first call the functions left or call the function right, or it may be first call the function right and call the function left. So we cannot know the order for this operator, for this increment operator. We do not know the order for the function calls. We cannot know. And only in four operators we can know the order. There are these four operators. And for your questions for this operator, we learn this operator in if-else statements. Do you remember? Which is such as, I just use A, B, and C represent the expressions. However, it's not correct. I just use it to help you to understand. We write this operator like this. Right, we write this like this, which means that if the A must be evaluated. If the A is evaluated, if the A is true, then we will evaluate B. And then if A is evaluated at false, we will evaluate C. Maybe you forgot those operators. You can check it in the section at the if-else statement. In the selection of the if-else statement, we introduce this condition operator, which means if the A is the condition and B is some statements, is a statement to calculate, and C is another statement. Is another expression. Sorry, is an expression, not statement. So they are different things. They are not related to the Fibonacci calculation. Tang, what's your meaning for the value is stored in the int? Maybe you can look at the slides in the if-else statement. If A is true, then do B. If A is false, do say? The the array n is array, right? And array has not do not have type, right? But the elements in the array has type. Now, and the elements in the array n type is int. And the n0 will take the first element in the array. So this is the element in the array and whose type is int. So what's your questions about the tower of the Harvard? The tower of the Harvard. What's your problem? In the else. Sorry, you mean you cannot understand what's the code here? Maybe you can first think about it. We now has n desks, right? We have n desk. Now we want to move this n desk to another road. And now we just need to think about it. We just move the first n-1 desks to another road. So we can take the remaining desk to a road. So after this step at the 20, then we will have some n-1 desks on a B, for example. Then the other desk will be a C. So after this step, will be still be A. So in this step, we can just simply move this A to move this desk in A to C, right? This is the line the 21 is doing. So after those two steps, we can just simply put the n-1 desk at the middle road, for example, to the right, to the C, to the right row. And you do not need to consider how we can move those n-1 desks. You just think, okay, the function can help do us. And then you read those 3 lines again, maybe, to think about this logic. We just need 3 steps, right? If we have knowing how to move the n-1 desktop, we have knowing, you can assume that we have knowing how to move the n-1 desk. This is the things doing by this function. So this n-1 desktop can be first moved to a B, and then we can move the next one, the next desk n to the C. And finally, we move this n-1 desk to the C. So we just need 3 steps. And the 3 steps are showing in these 3 statements. The binary tree is a tree data structure, and you will learn it in the future. Which is a data structure, and it's a tree data structure, and every nodes will have 2 sons and 2 sons nodes. And it is hard to explain at this point. It's just a data structure. If you are curious about that, maybe you can Google the binary tree. and there are many materials about the binary tree and the binary search tree. It's a tree data structure. Maybe we will introduce it in our lecture. I remember maybe lecture 11. If you want to know it now, maybe you can first Google it and see this data structure. Which means that in recursion, we can easily to debug the code. For example, in these situations, when we debug, we can easily find where we wrong. Maybe we wrong in the base cases. Maybe we wrong in the other cases, and how our logic is whether our logic is right or not. So the recursion usually help us to debug. But in the for statements, because we write many things in the for statements, and it does not have the clean structure in the for statement, the body of the for statement. So usually the recursion will help us to debug, but not always, just usually. Debug is to find the error in your code. Wide order of variables in a parameter list in changing in 920. Wide order. Maybe you can think about the logic, as I introduced before. So you can know why we should change the order of the variables to think about this process again. And for example, maybe I use the maybe I use this to help you understand. For yes, we must do it. You if you understand the logic, you can understand why we change the order. For example, in these cases, okay, and this is A, such as this is A, this is B, and this is C, okay. And the 20, in the 20, we move those two to here. This is the thing the 20 doing at the line, the statement the 20 doing. And then the line, the 21, we're doing something like this. And in the 22, we're doing things like this. So we finish it. So we should change the order. Because why we change the order? Because we need to move these things to the second one, not the third one. So we change the order. right? Do not to think about how we move those two together. It will be done by this function itself. Just assume that those two can be moved together. Do you understand? And has any other questions? Because we do not just move those, because we need to move those two to here, not here. So we change the order. We need to move it. And the first time, at the first step, we need to move it to here, not here. So we change the order. It's based on our requirement. Do you understand this process? Do I Okay, thanks, Tang, and also has a nice day. So, King Hong, do I address your consent? Yes. Yes, first time step, we move those two, or even more, to here. And then the second step, we move it here. And the final step, we again move those two to here. So this one, the 20 here, is the first step. We move those two here. Do you know the process? Why those three statements can help us to do the things? Yes, great. So do you have any questions about this lecture? Or the question about the array? If not, maybe we can stop here. For assignment 1, the Q5. What is the problem for Q5? We should write code. Could you pass the questions for the Q5? I do not remember the question. Yes, if it's a wrong month, you just print. Okay, you input some in void value like this. If the month is a wrong number, you can just print so and see that you input a wrong number. Yes, the same thing. Yes. For assignment question 3, can you accept me to type the figure with blocks, as I try many times to type figure without blocks and I cannot get the correct figure? Yes. However, the user in real world, the user will type everything that you do not want he or she to type. So when we write a code, we should to consider all the situations and to help the user to type the right things. And for the assignment 1, question 3, can you accept me to type the figure with blocks? And I try many times without block. Sorry, I don't know your meaning. King Ho for the Q3. Yes, it's a typo. Do you see our remarks and our emails and sent? We should this should be this. It's a typo, and we correct this typo in the should be this. Sorry, I write. Sorry, you can ignore this. Okay, print 4. Should be the print 4. You cannot do something like this. You can only use the 3 statements we list. Here we see that other formats of the print 4, different from the 3 statements, are not allowed. You cannot directly use other print 4 statements, just use the 3 statements we list in the assignment. If you use this format, maybe you will lose the score. The hint is that you can use the 4th statement. The hint is that maybe you can use the 4th statement. for one more submission, and I already before the classification email. Use the double. Can you open? Sorry, because every student has the 3 submission opportunities, so it's unfair to other students if I open another opportunity for you. However, and also those remarks and the emails, those remarks and this information are already been the original version in the assignment 1. That's we just to remind you, so use these remarks because some of you ask the questions about this. However, the requirement is in the original one. However, the requirement for the assignment can only use those 3 statements are also showing in the original version. In our original version about the assignment 1, we see that we can only use the statements, the 3 statements, and cannot use the any format about the print form. We have already given the hints is that you can use the 4 statement. However, we cannot tell you the solutions and the answers because it is unfair to other students. And after the grade the assignment 1, we will release the solutions. For Q2, you use the double. It says it may cause data loss. Sorry, I don't know your meaning about the Q2. And the contents in the we have introduced the IDE at the first lecture and the first tutorial in a very detailed process. Yes, I cannot provide one more submission chance to you. If I provide one more submission chance to you, then I need to provide one more submission chance to all the students. If I do not do like this, then it is unfair to other students, right? And we have already seen in the we have already seen that every student has 3 opportunities. Yes, I know maybe you will have some errors and some typos. So I give you 3 opportunities to submit, not just the one. No, because the brothers is just the int type, right? So it just some integers. You do not need to consider this situation. If we see this number is an integer, then it is an integer number. Can have any situations in based on our description. So read this. Read the question carefully. We see the number is an integer, or a unsigned integer, or a negative integer. So maybe it should include D is a non-negative integer. So based on this description, you can know that D is a non-negative integer, right? Yes, yes, you can also understand it as a position. So you can know the answer about your question. If you consider all the situations, you will not lose the score. For example, if you divide something, however, you do not judge the thing is zero or not, you may lose the score. It's just an example. Okay, if you have no questions, maybe we can stop here.